All right, so I know we went over some U substitution last time I was in and basic integral rules. So we're going to use U substitution to integrate a trigonometric, exponential, and logarithmic function. So it's basically just using U substitution to integrate more complicated or like transcendental functions. So remember, here's a list of our differentiation and integration formulas, and e to the x, the derivative of e to the x is e to the x, so the integral of e to the x is just e to the x plus c. And remember here, derivative of ln is 1 over x, or x to the negative 1, and the integral of 1 over x is ln x plus c. All right, so examples. So first we have the integral of cos 4x dx. So my u would be basically my inside function would be what we're taking the cosine of. So it's cos of 4x. So for this one, my u equals 4x. My du, so my derivative of u. So derivative of this expression would just be 4 dx. So when I look at my expression, it's easy to replace this 4x, right? It's easy to just say cos of u but this 4, we don't have a 4 on the outside of cos. We don't have a 4 multiplying the cos. So remember what that means we have to do is we're going to put 4 here. So now we have our 4 dx. We're putting 1/4 outside the integral. So now I'll have my integral, this 4 and the dx get replaced with du. And I still have this 1/4 on the outside. So now I take the antiderivative of this, and I'll have the 1/4 stays the same. Antiderivative of cosine is sine. Then the u comes in, and instead of du, the du goes away, and we now have plus c. Now, just like before, our last step is to go and replace the u with this expression here. So I'm going to replace the u with 4x. I want the equation in terms of x at the end. So equals 1 over 4 sine (4x) plus c. All right. Now, one thing to recognize here, one thing to recognize here is when we just have cos of a constant, or this is true for any trigonometric constant, so sine of like some constant number times x, really we can do this problem without any u substitution at all. Because what we can see is that there's always going to be this pattern. And what the pattern will be, and this is only true if it's just a plain number here. So it's not x squared, it's nothing fancy, it's just a constant times x. the pattern is we just take the antiderivative of the original function, which is sine, keep the inside function 4x the same, and then all we're doing is, because there's a constant here, is we're just multiplying on the outside by 1 over the constant, or the reciprocal of the constant, and then we're adding c on the end. So really, this one is something that there is a shortcut. You don't need to do u substitution at all. We can just go ahead and do it like this. All right, let's look at number 2. So number 2 is a little bit complicated. So we could say like, okay, there's this inside function, and so we substitute u in, and if we do that, we still though have sine times cosine. So sine times cosine is a little bit of a problem because we haven't learned how to undo multiplying expressions. So I want to say, is there an expression that's the derivative of the other? So is one of these, is sine the derivative of cosine, or is cosine the derivative of sine? And when I look at this, I say, yeah, cosine is the derivative of sine. So I'm going to take this expression, this cosine, and make this, I'm going to take my my sine, and I'm going to make this my u, and then I'm going to take my other expression, my cosine, and I'm saying cosine is my derivative of u. So my original expression, my u, equals sine 4x now my derivative of sine, so my derivative of u is going to be here 1/4, and derivative of sine is cosine. For x dx. So remember, I got the 1/4 because when I took the derivative, we have to use the chain, or sorry, little off today, guys, a little sick. My derivative of this is 4 cosine 4x. Because I have to use my chain rule, the derivative of this inside expression, derivative of 4x, is just 4. So it'll be 4 cos 4x dx. From there, I see that I'm missing this 4. So I'm going to put the 4 on the inside here. And when I put the 4 on the inside, I have to multiply by 1 over 4 on the outside. So now I'm going to have 1 over 4 times the antiderivative. And I said my sine 4x is just going to be my u. And my cosine my 4 cosine 4x is going to be my du. So I have the 1/4. I integrate u. This is just going to be use the power rule. Remember, there's an invisible one as an exponent, so I'm adding 1 to my exponent. and it's becoming u squared. And I'm going to multiply it by either reciprocal or the same as dividing by the exponent. So I'm multiplying by 1/2. Now 1/4 times 1/2 will be 1/8. U squared plus c. And now I'm just substituting my expression for u back in to get 1/8 times sine squared of 4x plus c. Sorry for the errors there, guys. All right, moving on.